Good morning, everybody. Well, firstly, I would like to thank to the committee of this meeting to give an opportunity to present our research. My name is Kusworini Handono from Indonesia. I would like to share our research about the regulatory T-cell compensation failures is possible mechanism to the dysregulation of immune response in murine model of SLE. We have nothing to declare. As we know that the Treg is a subset of T cells which main function in regulating inflammatory response, including in systemic lupus erythematosus. Several studies in humans reported a decrease of Treg subset in SLE. However, a different result was found in Indonesia and other Asia-Pacific countries that show an increase of Treg subset, indicating a compensatory mechanism against inflammatory condition in SLE. Our previous study in humans showed not only the percentage of Th17 was increased in SLE patients compared with healthy controls, but the percentage of Tregs higher also in these patients. The ratio of Treg and Th17 not significantly different between patient and healthy control. We also found that the serum level of TGF-beta lower than healthy control. There was an experimental study reported the other groups that show the critical roles of Tregs in development of SLE-like disease in the mice. When Tregs were deleted from mice, they developed a clinical pictures of SLE-like syndromes, which included the appearance of anti-nuclear antibody and markers of inflammations. When Tregs were injected into these mice, SLE-like features will disappear. Based on the controversial research of the previous study, we want to know the role of Tregs in Preston-induced lupus mice. Our research conducted on 48 female biopsy mice 8 to 12 weeks old, divided into two groups. The first group was 0.5 cc Preston-induced intraperitoneally, and the second group, as a healthy control, was injected by PBS. All the mice were euthanized at 8, 16, 24, and 32 weeks after injection. The percentage of Tregs, Th1, Th2, and Th17 in spleens were measured by flow cytometry. And the serum level of ENA, IL-6, and interferon alpha were measured by ELISA. Pristan, or TMPD, is a mineral oil may induce lupus mice by stimulating of productions of interferon alpha or beta by immature monocyte. MCP1 is produced and promotes the accretion of immature monocyte from the bone marrow. These cells enter the circulations, including chronic inflammations and lymphocyte activations to make the lupus-like disease. Apoptotic cells provide autoantigen to stimulate the T lymphocytes. Our study has successfully developed lupus mice with the clinical manifestations included malaise around 20%, arthritis around 75%, proteinuria more than 66%, ascites, and alopecia. This is the picture of our lupus mice, malaise, and then ascites, And then this is alopecia. The arthritis in the mice developed progressively by the time. The arthritis score was significantly higher in week 24 to 32 compared with before. Our research showed that the percentage of Treg had steep increase at the week 16, but it decreased afterward. There were significantly different of Tregs between pre-stun-induced mice and healthy controls at 16 and 24 weeks. Now we can see the profile of T helper subsets were almost the opposite of Treg profiles. All T helper subsets had decreased at 16 weeks, although it increased afterwards. As shown here, the profile of Th1, Th2, Th17 almost similar. We also found that there were negative correlations between T helper cells subset and Tregs. In this slide, we can see the profile of serum level of anti-nuclear antibody IL-6 and interferon alpha. Increase at 16, 24, and 32 weeks, and a negative correlations between percentages of Tregs with ENA and interferon alpha, but positive correlations with IL-6. Treg compensations against T helper cells, autoantibody, and pro-inflammatory cytokines productions was present at 16 weeks after pre-stun injections. Declining of Treg percentages was found at 24 to 32 weeks after pre-stun injection and negatively correlated with other variables. Compensation failure of Treg has been correlated with poor Treg function in SLE. Elevation of pro-inflammatory cytokine was considered to be a factor which contributed to Treg dysfunction and T helper cell resistance to Treg in SLE. Our conclusions: first, early increase of Tregs in murine model of SLE is considered to be a compensatory mechanism of Treg against inflammatory response in SLE. The second, reduction of Treg percentages correlated with the increase of T helper cell subsets, autoantibody, and pro-inflammatory cytokine productions, and indicated failure of Treg compensation in murine model of SLE. I would like to thank to our research team from Brawijaya University, and thank you for your attention.